So how is everyone this afternoon?
Good.
Good. So it's the last session of the day, so you can just kind of relax. If your brain's not already completely full of other information. So thanks for coming to my Interneting Your Things talk. It's a small room, so it's nice and small, and I'll probably have lots of room for Q&A afterwards. So if you came here with a question, feel free to ask me at the end because I'm up for answering anything that I can answer. So I'm Pearl Chen. And I actually brought this name badge with me. It actually blinks my name in LEDs. And so I'm from Canada, and thanks so much for DevWeek for having me back again. And so my name is Pearl Chen, and I have to admit I have a microcontroller addiction problem. I keep on buying microcontrollers, and sometimes I use them, sometimes I don't, but I just have this vast collection of microcontrollers. And I like to buy these microcontrollers under the guise of work because back in the day, in a former life, I dropped out of computer science and became a new media artist, but not that kind of art where it's like paintings, but art that you were expected to interact with, so things that you could touch, or you would enter a room and it would sense that something has changed. So it was interactive art, and the program that I was in was called New Media Art. Back in the day, it made sense to call something new media, but now new media is old media, so it doesn't make sense anymore. So most of the time you hear it as interactive art. And a lot of people don't really understand what my background is, and especially I'm here at a software development conference, and I am myself a software developer, but I have this kind of weird background. So I want to play show you 3 examples of artworks that I really like that sort of show where I came from. And this is a project from Kyle McDonald and Matt Metz called Blind Self-Portrait. So what happened in that video was yourself as a participant, you go and you sit down in front of a computer webcam. So you sit down in front of it, and then you rest your hand on a platform and you hold a pen on top of a piece of paper. And so what happens is the webcam, it sort of takes a video or picture of you and uses computer vision to analyze what you look like. So it tries to figure out where your eyes are, what shape your nose is, the shape of your head. And then you actually close your eyes, and then the computer starts drawing you. So the platform starts moving. And it's a really interesting experience because, it's you kind of holding a pen, and you're kind of drawing your self-portrait, but it's actually the computer seeing you. So it's this really interesting interplay of who's actually making this artwork. Is it kind of you or the computer? What is the artwork? Is it the experience of sitting there, or is it the piece of paper you get at the end? And so for me, I did my blind self-portrait making a zombie face, and I think it turned out pretty well. Another piece that I really liked that was actually from 2001 is from an artist called Janet Cardiff. So this was an installation at the San Francisco Museum of Modern Art. It was called The Telephone Call. And so what happens is that you get to the museum and you ask to see the telephone call, and they give you a handy cam and headphones. So you have to carry around a handy cam and you have to carry around and point it at things. And then you have audio in your headphones. And it's kind of like a museum tour in some ways, because you're kind of holding up the screen and you're seeing the museum filmed at a different point of time. And this was 2001. So this was sort of like really early augmented reality. But the interesting thing was that it wasn't like a museum tour. It was actually more of a spy mystery espionage story. So it was actually kind of creepy. So it wasn't a museum tour where it tells you about the artwork. You're actually being led by the artist's voice and the video to tell you to go places in the museum. And it's really interesting because not only do you have this handy cam, but the way she records the sound is binaural. It's called binaural recording. So she has this mannequin head that she tapes microphones to both sides of the ears, and then records the sound while walking around. So when you get it played back, it's sort of like supersonic stereo, and it actually really feels like you're in that space that got recorded, because you can really judge distance of like where objects are. And when someone is whispering in your ear, you really actually feel like someone's whispering in your ear. And so it's really interesting because at one point in this spy story, she leads you to a door that says emergency exit only. And as a person, you wouldn't typically go through that door. But in the video and the audio prompts you to go through the door, and someone goes through the door. So you have to, at that moment, decide, should I go through this door that I really shouldn't be going through? And so there's like this really interesting audio clip where you end up in the stairway, and if you do listen to this audio clip at home with your own headphones, it actually sounds really creepy, because it does sound like someone's in the stairways with you. But when you're there in person, like no one's there, but the audio is so real that you just get kind of scared. So I thought it was a really great installation just using technology, and it was very foresighting of how people want to use augmented reality today. And kind of my last piece that I'll kind of show you to give context is it's actually a London company called Qt Circuit, and they do a lot of wearables. So this isn't an art installation, it's actually a creative wearable. It's a Bluetooth accessory for your phone, where you wear this sleeve that has pleats in it, and when someone sends you a text message, the pleats actually ruffle up a little bit, so you can tell from the pleats and the pattern in it who's calling you or who's texting you. And then it's really interesting because it's not just a notification system. When you want to reply back with a text message saying, I'll call you later, you actually like smooth down the pleats on your sleeve. So it's very physical. It's a very physical interaction. And it's really interesting because this was done in 2005. So 10 years ago. And I think it still looks really great. And so for me personally, when I started getting into electronics, I was really obsessed with lights, so I built this LED light sculpture where I actually had to hand solder about, Canadians say solder, by the way. I had to almost 1,000 LEDs I had to do by hand, because back in that day, you couldn't just order this magical sheet of LEDs. And then because there was no overnight shipping of circuit boards, I was running out of time, so I had to hand do all my circuit boards. I did 10 of these. But I kind of realized that I wasn't going to make a living out of being a new media artist, I could make a living, but I'd be really poor, so I became a web developer. So I made sites like this for Nike, like companies, and I really enjoyed that part also of my career, because I really got into deeper into front-end development and coding. But I always continued to do hardware as sort of a side project. So I kind of realized actually that I could still continue working in that sort of interactive space, but do it under the guise of teaching. So I would actually do workshops where, this is one of my workshops where it's an Arduino-powered robot, but you could control it using your Android phone. And it's not as creepy as it looks here, it's just because it's dark. It's actually very adorable. But I would actually teach these at workshops that I would do. And then, crazy enough, I realized that people will actually pay me to teach technology. So I've done contract work for Google, specifically with the Google Chrome team, doing tutorials for front-end web development. And then, crazy enough, like nowadays, I actually work with Intel's IoT department, their Internet of Things department, as a developer relations. So I help improve their onboarding experience, specifically for people at hackathons. So it's kind of great that, you know, after all this really weird career, I'm kind of actually back at where I started. So it's great that I get to do this as my day job. And I always kind of wonder, you know, what would my career have been if I was born 5 years later? Because I graduated in 2005, but that was actually the year that the Arduino was created. So, you know, if I was just, you know, a couple more, like born a few more years later, I would have had the Arduino as my background. And if you've never, actually, raise your hand if you have heard of an Arduino before. Okay, so keep your hand raised if you bought an Arduino. Okay, keep your hand raised if you bought an Arduino, but it just collects dust. So that's like a lot of people. And it's really interesting because Arduino is quite easy to get into, but there is still some barriers, especially if you're a software developer. And I'm going to guess that raise your hand if you're here because you're a software developer. Okay, so if you didn't raise your hand, what are you here? Who, like, are you, what are you? Are you a hardware, any hardware developers here?
Used to.
Pardon?
Used to.
Used to? Okay, so we got a bit of a mix, but mostly mostly software heavy. For myself, I actually learned programming on something called a basic stack, which was a precursor to the Arduino. And the thought of having an easy to program microcontroller back then was actually, like, it doesn't seem to make sense now that there was not an Arduino or some sort of easy to program microcontroller. But back then, the basic stack was actually quite innovative for its time. And a lot of artists and hackers and tinkerers just really kind of gravitated towards that before the Arduino came out. So I did kind of learn microcontroller programming on the basic stamp. But even before that, there was probably a pretty long history of hardware and microcontroller development. But I kind of tried out the microchip PIC, which is kind of like really cute, like integrated circuit. And it's kind of interesting because when you kind of think about an Arduino, you buy an Arduino for $30 and you kind of just have an Arduino. But the chip, or the microchip PIC, their business model was actually to sell you the chips for really, really cheap. So you could go and buy a chip for $5, or if you were buying in bulk, you could buy a chip for $2. But then they would like charge you out of the wazoo for the programmer that you would put the program on the chip, or a compiler to take some sort of high-level language, and at that time it was BASIC, it was to take like a high-level language like BASIC and convert it into machine language. So they would charge you extra money for all these, like this tooling. Where on the flip side, Arduino makes you pay for the hardware, but the tooling is free. So it's just really interesting flip in terms of the business model of hardware. And then Arduino really took off, partly because of cost and community. So community was a really big selling point for Arduino, because if you were just getting started and you were kind of scared of hardware, you could always just Google something and you would find the answer. Like, there was a huge, helpful, supportive community for Arduino. And then on the hardware side, the thing that kind of made Arduino really grow is shields. So shields are these add-ons that you just pop onto the top of an Arduino. And if you want, you know, Ethernet capabilities, there's a shield for it. If you want an LCD screen, there's a shield for it. If you want Wi-Fi connectivity, there's a shield for it. So really there's like a shield for everything, to a point where you can make like shield sandwiches, because you can just stack them on top of each other. And so if you think that Arduino was 2005, something happened in 2009 that actually, I think, really changed the game for Arduino and hardware, which was Kickstarter. Kickstarter launched, in 2009. And then you saw in 2012, the Pebble, the first generation Pebble, was one of the first huge successful consumer electronics products to launch on Kickstarter. Did anyone in this room kickstart a Pebble or buy one after the fact? Just one? I'm surprised. Actually, when I got mine, I was kind of like, smartwatches, I don't need one. But then when it hit Best Buy, I was like, okay, I'll get myself a smartwatch. So I wasn't part of the Kickstarter, but I did buy a Pebble after the fact. And so Kickstarter really showed that crowdfunding electronics worked. And then interestingly enough, in 2012, same year, another microcontroller came out called the Makey Makey. And it was definitely an internet darling sensation because it was had a really cute video, and it was actually this microcontroller that was invented for kids, but I find that it's really great for adults too. But that came out in 2012, and I think since then, if you check on the Kickstarter website, there's a new microcontroller that's trying to launch every month. Some get kickstarted, some don't. But I do feel that a lot of small players are entering into the market because of Kickstarter. And I would argue that it's actually the decline, we're seeing the decline of Arduino, the brand. So not the maker movement, that's still nice and healthy. And Arduino itself, like, is still going to be very pervasive, but I actually think we're in a sort of a beginning points of where Arduino is on the decline. Because there are all these new players entering into the market. So if you kind of think like the Raspberry Pi was kind of a surprise hit for the maker movement. It was, it's UK invention, but it was meant for kids to learn programming on because it was $35 and you could put a computer in front of every student. But then somehow the hacker community got a hold of it and then turned it into a microcontroller. So it just became this really surprise aftermarket that they weren't expecting. And that's definitely eaten into the Arduino mindshare. And then you have really big players like Intel, who have always made chips entering into the microcontroller market. So they have 2 microcontrollers out right now, 3 if you consider the generations, and they have a 4th one coming out pretty soon. But then there's all these like little startups out there. So Spark and Punchthrough, they're 2 startups, 2 hardware startups in San Francisco or the Bay Area. And they have less than 30 employees each company. But they're definitely making some waves in terms of microcontrollers. So you're seeing these sort of like, these big players like Raspberry Pi and Intel coming out and competing directly alongside these really small, like under 30 employee companies. And then you have other companies that are really geared towards specific developers. So Tesla is a board from a company called Technical Machines, and they actually have a microcontroller that when you develop for it, it's completely JavaScript. So if you can imagine how big the JavaScript web development market is, the Tesla is really hitting that market. So you have microcontrollers that are for specific niches now, instead of just the generic Arduino. And I think a lot of this we're seeing happening. You don't have to read all this text. The main thing is that what we're seeing that's happening right now is that like we went through like the first revolution, which was manufacturing. The second revolution was transportation. And now the third revolution is mass customization, because we have 3D printers, a lot of rapid prototyping tools like laser cutters, CNC machines. Those sort of things are all interplaying with people in the maker market, where people are really interested in like these consumer products, but customized specifically for them. So you're seeing this mass customization, and all these hardware startups are really interested in entering into this space. So you're seeing Arduino, or did I put it next to the side? You can see that Arduino is kind of falling to the wayside, because Arduino was meant as a prototyping tool, like you would never take it to market. But all these other startups, such as Spark and Punchthrough, they're building microcontrollers that you will eventually put into your end product. So you can go from prototyping to production. using like minimal changeover time to like go from one chip to another. Like you would just go prototype on one board and continue into production with that same board. And so that's a bit of a background of what the landscape is. And so if you're here, you might be running like, what are all the things I can kind of do with, microcontrollers and hardware that can talk to the world. And I think the biggest thing is that you can turn dumb things into smart things. So like in my description in the website, I put down like, Nest was a great example because the thermostat felt pretty dumb for a pretty long time. But then Nest came out and added sort of like this really nice UI and Wi-Fi connectivity to the thermostat. And it blew up and became a really big home automation market. And then I put in another, actually I didn't put in a picture of this, and you may have not tried to look it up, but where's my mouse cursor? I don't think this is it. I put in a link, or like I reference, oh, it is this one. I put in a link for botanicals, and this is actually a really old project, but it's a project that you put a microcontroller into a potted plant, much like this one over here. And if you're like me, you always forget to water your plants. But this like little botanicals, you put it in, it has a moisture sensor, and then when it's feeling low on moisture, it will actually tweet out that it needs some water. So it sort of takes these things that you don't necessarily think of having a voice and sort of giving them a voice. And these things are going to get cheaper and cheaper. So even though this was made as sort of a funny art project and collaboration, you could definitely see this being a home consumer product. Like if you could buy this for $5, like who would buy one right now just because they kill all their plants? Like I would definitely buy one. And so you're seeing a lot of this turning these dumb things into smart things, and generally for quite cheap. And another thing that you're kind of seeing is an increase in ambient notifications. So right now we're in this period where we're very screen obsessed. Like we look at our phone like all the time. We look at our TV screens. We look at our computer screens. But we're seeing like sort of a new sort of breed of products that are just about ambient notification that might, when you get a Twitter alert, it's just like a light changes. So something that's really similar, but it's not a screen. Or like for another example of it, like a screenless experience is cars that have keys that when you walk up to the car, your car unlocks. So those are like very interesting interactions because it's very screenless, and it just requires sort of some contextual awareness, which is kind of another tie-in, is that a lot of the products right now, or things that you might be interested in creating, are projects that are kind of aware of like where your body is in physical space or where you are on a map. So location awareness is quite big in terms of having a product that can talk to the internet or talk to other things. And the huge thing about all these, besides maybe the first one, is that context is king. So a lot of the stuff that you might want to build that is smart will know like where you are, who you are, and give you the information exactly when you want it to come up. And so if you're here, you're kind of like, oh, I don't know what to buy or how to get started. And so I kind of put some lists in terms of what are some questions you might ask in terms of when you first go shopping for a microcontroller. So obviously the first one is price. You got to figure out what your budget is. Most microcontrollers rarely go up above $100 now. I will show you some examples of things that do go above $100, but for a bare bones kit, you're typically looking in the under 50, under 30 category. If you have a lower budget than that, there are a few other controllers out there, but the first question you probably ask yourself is price. And then the second question you kind of have to ask yourself is, what's the form factor? Like, is this project going to sit in this big room where I have lots of space and I don't have any restrictions? Does it have to be like a really tiny space? Does it have to be like so small that it works as a wearable? So you would kind of ask yourself, like, what is the form factor? And then you would ask yourself, what kind of connectivity do you want? Some projects you can go without. This talk is more specifically on things that can talk to other things. But you would ask yourself, is it okay that it's a wired Ethernet connection? Or do you want Wi-Fi, Bluetooth, or even Bluetooth low energy? And then I think I think this fourth one can be sort of independent of other ones, but programming language might actually have a huge influence on whether or not you choose a microcontroller. So if you are a JavaScript developer, you may feel that trying to jump into C++ may be a little bit too much for you, so you would want to look for a microcontroller that actually runs on JavaScript. And like surprisingly enough, quite a lot of microcontrollers today do run on JavaScript. And I'm sure if you were to have like your own favorite language, you would be able to go and find a microcontroller that actually runs that program. Oops, sorry. And the interesting thing now is that you kind of have now two classes of microcontrollers to choose from. Either a microcontroller that's more like an Arduino, where it's embedded and it runs one sketch or one firmware piece application, and it just runs that, and that's all it does. That's all it can do. Or a Linux-based runtime environment where it's actually like a little computer, like the Raspberry Pi, that just runs full-blown, not full-blown, but like a modified version of Linux. That means that you can write any language on it. So it could be C++ or JavaScript or C# or Python. So it kind of opens up the possibilities for you as a programmer to go in and choose any platform that runs on Linux, because if it works on Linux, it's going to work anywhere. Or it's going to work, if it's going to work on Linux, it's going to work on any of these boards that run Linux. And I think a really key point when you go out and choose a microcontroller is see what kind of community support they have. Look at their support forums and see that people actually answer questions when they're posted, because you never want to buy something and then feel lost. So if you can find a board that you like and that you see that the support forums are alive and kicking, then you probably have a good choice. And so I'm going to give you a few microcontrollers that I like. In this category of no programming, and by that I mean no embedded programming. So if you're a software developer, you might be just okay with writing software that runs on your computer or web applications. So these are kind of classes of devices that don't have any embedded software. So who has heard of LittleBits before? Okay, so LittleBits. Not working out well. Let me just change my screen setup. All right, that's better. So LittleBits is really interesting because it was sort of designed for kids. But again, I think that a lot of stuff that's designed for kids is actually great for adults because it's very stress-free working with some of these things that are made for kids. But the interesting thing about LittleBits is that it's a bunch of modular components that snap together using magnets. There used to be an animation here, but it might not be showing up. Let's see. So Little Bits is a really interesting ecosystem of components. So it doesn't actually have to have a microcontroller. They do have a little Arduino microcontroller, but you buy all these like little discrete components. So a battery component, a light component, a light sensor, motors, and then you just snap them together to sort of create a circuit. And then if you build sort of a creative housing for all of your like little bits, then you can kind of create all these like little things that you saw in the video. The unfortunate thing about little bits is that they are expensive. So this is one of the few categories that go above $100, because if you want to buy a kit, let's say you want to buy this smart home kit, you can kind of see that it is already going to cost you $250 for all these tinkering things. But it is great because you don't have to do any programming. If it's something that you want to do with your kids, then this actually might be really fun to be able to work on things together with your kids. But I think a really interesting thing is last year they announced a cloud little bit. So a lot of these components can actually be hooked up to the cloud and be triggered using your smartphone or some sort of like web activity. So it is really great if you really don't want to do any programming at all. You can go with little bits. And so the next one that kind of requires very minimal programming is the Makey Makey. Who has heard of the Makey Makey before, besides the people who came to my workshop? All right, so people at my workshop tried out. I had a workshop yesterday here, and a few of them tried it out and played some video games in a really interesting way. So.
And I'm Eric. We're graduate students at MIT Media Lab.
So the Makey Makey is a really interesting microcontroller because it is actually an Arduino. That the guts is an Arduino, but the hardware is set up in such a way that anything that can sort of conduct electricity, it can detect. Yourself as a human, you have water content, so you are conductive. Things that are metal are conductive. So you can kind of like create some interesting interfaces, sort of mixing together things that are conductive versus not conductive, like rubber. So I've definitely seen some interesting things come out of Makey Makey where I do a lot of workshops with Makey Makey where even within 2 hours, I've given people with no programming experience and with some programming experience, and they always come up with like really wacky stuff. One person that I had in a workshop, he found a game called Not Pac-Man. And so this was a workshop that was kind of geared towards game developers and game designers. So it's instead of playing Pac-Man using your arrow keys to move your character around, you actually use gravity to move the Pac-Man character around. So this is something that he just kind of found, but you can imagine that if you were a game developer, you could build this yourself. So it's an interesting interplay on the regular game of Pac-Man. But what he did was he actually hooked up the Makey Makey to two tilt switches on his shoulders. So to play the game, you actually have to like lean over and do this while playing the game. So you can see that like for him to try to prototype this idea of physical gaming, he didn't have to do any programming. He just had to find a game that kind of fit the thing that he wanted to do. He taped some components to his shoulder, and then he was able to prototype this physical gaming experience within an hour. Or even less, I think, because I think he was puttering about for a bit. So you can see that's kind of things that you can kind of do with Makey Makey is, take software that you've already developed, and as long as it takes in keyboard commands, because that's what the Makey Makey does, it just sends across like the up arrow key press, the space bar, the click, it just sends that off and pretends to be a mouse or a keyboard. And so your application, if it already takes in keyboard commands, you can just hook into the Makey Makey right away. So it's really great for rapid prototyping. And you get to focus on just the hardware part you get to focus on the software part of it, sort of the screen experience. And you don't have to worry about the hardware part of it right away. Like you can sort of go back into that later. And it lets you experiment with these really big physical setups, like having a piano stairway. And one thing, I don't have the picture of it here, but you might have noticed that it's not a wireless sort of interaction, but you can buy Bluetooth adapters for the Makey Makey, so you can actually take your Makey Makey and turn it into a Bluetooth keyboard or mouse, and then it's completely wireless interaction. Or you can buy an OTG, like on-the-go micro USB to USB adapter for your phone. So then you can hook up the Makey Makey to your smartphone, even your iPhone, and then actually have an application running on your iPhone, and then have a Makey Makey become your controller. So it can become very mobile very quickly. So I do think it's a really interesting tool that if you really don't want to do any embedded programming or very minimal, you can kind of pick up a Makey Makey kit for $40 and just make weird piano games or something. Banana games, I mean, sorry. This is kind of an older project, but this is kind of where a lot of these like single-use, let me click on this link actually. So Twine is it's like a little box. It's all self-enclosed, but it's Wi-Fi enabled. And so you buy little boxes that do specific things. So you might buy a box that's an orientation box, and all it does is detect if it's been tilted. And when it has been tilted, it sends a message to a web server, which you can then hook into and write any sort of application that you want around that sort of web request. Let's see, there's a vibration motor. Sorry, not a motor, a box. And so the interesting project that I've seen out of using Twine and the vibration motor is that if you have a washing machine that's downstairs and you can't ever tell when it's finished, you can set up the vibration Twine box to tell you when it's stopped moving, and then you know to go get your laundry. So it's this really simple way of interacting with physical things in this very out-of-the-box experience, because you don't have to do any electronics with it at all. Like, it's just all self-contained. So a lot of these come in varying prices. So if, let's see what the price of a moisture switch is. So you can buy, these are actually getting kind of inexpensive, but you can buy, let me make this bigger. You can buy, I don't know why that's not going over there. You can buy a moisture sensor for $15. So you can see that it's not going to be as cheap as buying an off-the-shelf component, but you do get this sort of built-in web connectivity built into it. So it's very, when you just have an hour to tinker around, a Twine might be really interesting for you to get into hardware. Sorry, I don't know what I'm doing. Zoom out. I see. I think you know when you like hit a keyboard command and then you're just in this thing that you just don't know what you're doing? I'm in accessibility mode now, and I can't remember the keyboard shortcut to get at it. No. There it is, yeah, Option Command 8. Okay, yeah, like I remember that. Okay. Sorry. So those are kind of like three, so little bits, makey, and twine. Those are sort of three that require no embedded programming. And there's tons of other ones similar to these three. So this is only the tip of the iceberg. These are just three that off the top of my head, I know, and I've had good feedback from them. So do check that out if you just don't want to do any programming. And so if you're okay with doing some programming, there's a few boards now that actually come with built-in Wi-Fi. And Spark, as I mentioned earlier, is a company from California, under 30 employees. And they released, the first version that they released was the Spark Core. And it's actually very tiny. I think the picture on the monitor, the actual controller is probably only an actual eighth of the size of what you see on this screen here, because this monitor is really big. So it's actually very, very small. And what happens is that it has like built-in Wi-Fi, and then there's this Spark cloud server that runs. So you always have to be online in order for the microcontroller to work. And then you can program it over the cloud too. So you can actually send commands, program it, and upload firmware to it without even having to connect a wire. So it's a really interesting board that, you know, it sold for $39 for the first gen. But they just came out with the Photon. It's still in pre-order, but some people have gotten theirs already. But a Photon is only $20. So if you can imagine only spending $20 for a Wi-Fi enabled microcontroller, like that's actually like a really, really good deal. And they just came out with, or they're kickstarting a new device that I'm going to talk a little bit about later in the 3G category. But you can see that Spark is like really ramping up on the really cheap microcontrollers that you can go from prototyping to production with, because $20 is pretty good, and if you're going to sell 1 million of these things, you can get a good deal on it. So Spark is really interesting in terms of a player to keep an eye out on. And you can program it using an Arduino-like interface. So you actually kind of use their web IDE, which looks a lot like the, I don't know if Sublime Text. I don't know if anyone here in this room uses it. So it kind of looks a bit like Sublime Text as a text editor. Intel released the Intel Edison, I believe it was a year and a half ago, maybe a year ago. And so the Edison is interesting because it has built-in Wi-Fi and Bluetooth, and it also runs embedded Linux. So it's this crazy super computer in something the size of a big postage stamp. So it's really small, but really powerful. And the interesting thing about the Edison too is, besides the fact that it has like built-in Wi-Fi, is that you can program it using anything that runs on Linux. So Intel themselves, they release a couple tool chains that are useful for C or C+ developers. So you can use Eclipse. So that's an IDE that people are familiar with. So you can use familiar tooling. For JavaScript, you can use something called the XDK, the Intel XDK, to write your JavaScript. And then it gets pushed onto the Intel chip, and then it runs Node.js right on the Edison. So it is like a little mini computer. If you really wanted to, you could SSH or serial into it and write your own Python code right on the board and save it and have it control electronics. So it's a really interesting, powerful board that you can do quite a lot with. And let's see, so the pricing was on there for the Spark. And so the Edison itself is about $50 or $60 US. And then what you can do is you can buy expansion boards. So the Edison itself, when you just buy the module, it doesn't really do very much because it's meant to go and plug and play into different expansion boards. So you can buy an Arduino expansion board, or you can buy like little small breakout boards. There's a company called SparkFun that makes sort of like how you saw the Arduino shields. They make the Edison version of it, but it's like little stacks that you can put on each other. Actually, I'll pull that up. Better to show you a picture. And so they sell these like little add-on boards where, you know, you might have a base sort of add-on module, but then you would go ahead and sort of pair it up with other components. Like here's like a little screen. Can't see what that is. I think these are a bunch of LEDs. Can't even tell. They're just. This one's an SD card reader or a 3G card, can't tell. But they have like so many of these little Edison blocks that sort of like how you saw Arduino shields or the little bits, you just pick the functionality that you need and then you buy the add-on component and you just sort of stack them together. If you are really interested in sticking to Arduino, they do have an Arduino that came out a couple years ago called the Yun, which is interesting because it's both running Linux and Arduino at the same time. So there's actually two processors running on it at once. And it has built-in Wi-Fi and an Ethernet port. So it is something where if you're trying to stick to the Arduino ecosystem, it is an option. I believe a Yun is $80. And an interesting, also from California, is Electric Imp. And they sell something that looks very, very different than a microcontroller. It's probably more in line with the Twine that you saw, where it's a Wi-Fi enabled chip, but it looks like an SD card. And so you have like, let me pull this up. So you have an imp, and then you can actually set it up using lights, which is kind of weird. Like it'll be able to flash a series of lights into the imp, and the imp can kind of read the flashes of lights, so sort of like sending SOS signals, but it's really quickly and to the microcontroller from your phone. So it's really interesting setup. So there's kind of interesting technology going on there, but it's already Wi-Fi enabled. So you kind of have to buy into this imp cloud. So if you're the type of person who maybe you just kind of like doing sort of this middle layer, you don't like doing back-end stuff, you don't want to make your own servers, you can kind of buy into a system like Electric Imp where they take care of all the cloud stuff for you, and then you worry about the actual end product. And you can kind of see that sometimes the Electric Imp has ended up in a few consumer products like smart plugs. And so it's a kind of an interesting prototyping tool that you can take into production. I don't think a lot of people that I know of use it, but I do think it's a really interesting company because they have been around for quite a while. And then I think this is the last one in the Wi-Fi category. Tessel, I kind of mentioned them earlier as a microcontroller board that you can program using purely JavaScript. So if you are a Node or JavaScript developer, you would probably gravitate towards Tessel because it all runs on JavaScript. And they are pre-ordering the Tessel 2, so their second generation, which has built-in Wi-Fi, and I believe it has an Ethernet port. Yeah, it has an Ethernet port. And then one thing that Tessel is kind of heading into is also making their own modules. So if you're kind of, you want to use a motor, you would buy their motor module. So so you would buy a little module that would kind of be pretty modular and standard between all the Tesla modules. So you plug them into the same spot. And that way you don't have to know any like low-level hardware stuff. You just go buy the accelerometer module, or you buy their ambient light module, and then you can kind of plug in USB devices to it too. So it does become sort of like the Edison or the Raspberry Pi, where you can plug in USB peripherals, but it runs on JavaScript. So it's this really interesting like niche market where probably if you're some other developer, you wouldn't care about this at all. But for most JavaScript developers, you're like, this is insane. So the Tesla 2, that's on pre-order now. And the Tesla 1 still runs on JavaScript, but it doesn't have all this sort of Wi-Fi and Ethernet capabilities. And so an interesting new sort of market for a lot of these controllers is 3G. So, you know, Wi-Fi is not always dependable. Neither is 3G, but probably in most cases, if you're going to do some remote projects, you might want to go with 3G because Wi-Fi might not be dependable. Spark, they just kickstarted what they call the Electron. For $40, you can get a chip that runs on 3G connectivity. So you can kind of, it's interesting because Spark now has two sort of platforms, one that's Wi-Fi, one that's 3G. And if you like working in their development environment, you could kind of stick to Spark, and then you would never actually use an Arduino again. So I think it's kind of interesting where like this is kind of where you're seeing the decline of Arduino, is these small players coming in and taking over. And then the last, I think this is the last category, is built-in Bluetooth low energy. So Bluetooth low energy is a newer Bluetooth protocol that's really good for low energy sort of environments where you just need to send a couple little packets over. So it's not that you're sending over a file or anything huge. You just want to send like a little message like, hey, I'm moving, or like, hey, like my accelerometer says 59, or like, hey, my accelerometer says 60 now. So it's only for sending over like really small packages. And so the really nice thing about Bluetooth is that most of the time it can run on very low energy, so a coin cell battery, and it can last for 6 months or a year. So it's really good for those sort of projects that require just a little bit of messaging but needs a really long battery life. So one of my favorites is from Punch Through. They have something called the Light Blue Bean, and it's a pretty tiny little microcontroller that has built-in Bluetooth low energy. You can actually program it wirelessly, so you don't really need any cables to program it. And I did notice in my workshop that it probably is much better if you're a Mac person or an iPhone person to sort of prototype with the Bean, because it's much more geared towards low energy, which Macs and iPhones tend to have, but Windows computers are still kind of pretty iffy with what kind of Bluetooth they do have. So I do think Bluetooth low energy is going to be a huge protocol in the next few years, but it's only for some people. So I think the Light Blue Bean is definitely one that I recommend if you have a Mac or an iPhone. You can actually program it using your iPhone and iOS tablet too. And then there's going to be tons of similar projects to this, or products. This one is called the STMOTI. Who's heard of like iPhone iBeacons before? So iBeacons are this, it's built on like Bluetooth low energy. So it's kind of more about sending over really small packets. But when you kind of use it on the iPhone, it's really more geared towards location awareness. So the STMOTIs, they kind of are good for doing context-aware sort of projects where if you need to figure out if someone has walked into a room because they have an iPhone and they approach your module, that it fires an event. So it is one of these like new categories that are emerging, where it's Bluetooth low energy, and it's like little tags that you stick places, and typically they last pretty long time. Like they'll last 6 months or a year on a really small battery. So it's for like certain kind of products. And if you kind of think about the twine, how it was just like a little box that you bought and you stuck it somewhere, The Estimoti is a lot like that, where it's like a little tag that you stick somewhere and you kind of forget about it, but you can fire events based on location awareness. And I think finally, I'll just talk about things that need add-ons. So of course I'm going to mention the Raspberry Pi because it does have built-in Ethernet, but you can very cheaply buy a Wi-Fi add-on for the Raspberry Pi, and it becomes a very cheap microcontroller because it runs Linux on it, but you can still control electricity or things attached to electricity with it. And then of course there's a shield for that. So there's obviously tons of different kinds of competing Wi-Fi and Bluetooth shields. I think this was probably the one that I would recommend the most. But I think the caveat with the Arduino shields is that some of them are really bad. Like, I don't know what it is about them, but sometimes they're not as plug-in as play as you want them to be, which is kind of why I'm gravitating a lot more towards these microcontrollers that already have it built in, because it means that the microcontroller was built for connectivity. So the Spark was built for connectivity, and it has built-in Wi-Fi, and it's got like a really small form factor. So I don't see why I would want to choose buying an Arduino and a Wi-Fi add-on just to get that connectivity. I would probably just move to a Spark or like maybe an Edison. But it is an option to get shields for Wi-Fi, Ethernet, Bluetooth Low Energy, kind of anything that you can imagine. Oops, and I think I'm actually at the end. Okay, so one thing I kind of wanted to mention was those are kind of like my top sort of like microcontrollers or hardware-based projects that I would sort of recommend. And if you're just kind of like getting started and you just have no hardware experience at all, I do recommend looking at this company. They're called Seed Studio. They're based out of China, and they work with other companies to build hardware like products and sort of take their idea, turn it into production, and then distribute it, because they're mostly an online retailer. But Seed Studio has actually created their own set of components called Grove. So typically what would happen is that you would have an Arduino or some sort of starter board, and you would buy a Grove kit. So you can see here that the Photon, even though it's like still on pre-order, they have a Grove kit for it, where you get a base shield. So it just sits on top of your component, or it sits alongside of it. And then you get these wires that are 4-pin wires. And they're not really that proprietary at all. Like, you could make your own if you wanted to. And then you get these modules that are either input modules like sensors, or they're output modules like motors or relays, which can trigger like your light switches or something in your house. And then you just plug them into the base shield. So it requires very little knowledge of electronics. But the really good thing I think about the Grove Studio, or the Grove kits, and I'm not selling this because I get commission or anything, it's just because they're growing this really interesting ecosystem where if you do like using their modules, you might start off buying a starter kit for the Photon, but then if you wanted to, you could buy a base shield for an Arduino or the Edison, and then use the modules that you already bought with your other microcontroller. So that gives you a little bit of room to switch microcontrollers and see which kind of one fits with you, but then you get to keep the components the same. So it's a good way to sort of try out new microcontrollers by just having the same set of ecosystem of modules. But obviously, if you buy into an ecosystem, you're kind of in that ecosystem. So it's only for some people, but I do think that if you are just starting out, I do recommend the Grove starter kits, simply because you don't have to know any hardware. And even for me, even though I did have to learn some of that hardware, I've completely forgotten most of it because I'd rather my head be kept for like software stuff rather than hardware stuff. So I think the Grove's really interesting. And then same with what we saw with the little bits. Like, you can actually make some interesting projects with the Grove kits where you just make your own sort of casing for a Grove component, and it can kind of look really polished because the casing on the outside looks really polished, but the inside is probably like a mess of wires. But at least you know that you have components that you can kind of trust, which is just coming from Grove. So I think I actually have a lot of time for Q&A, but that was kind of like what my sort of overview was. I just kind of wanted to give you like some of my top favorites. The easiest way to get into it, which would be the Grove starter kit. And if you want to, I can go over, how to program an Arduino if you want to, but I think maybe I'll just open this time up for Q&A. Ask me anything.
You've left out a NetDuino.
A NetDuino? Yes,
Have you
so
experienced with that?
no. So you were kind of mentioning there's another controller called the NetDuino, and I believe it's C#. Well, you program with Studio, yeah. So obviously, do you have information on the NetDuino?
I've got a NetDuino 1 Plus. I haven't really done a lot with it. I'm just starting to. But I wondered if you had any experience of popping the shields on. It's got quite a lot of features on it, but the shields that you get from SparkFly or some of the other suppliers, whether they come with sort of .NET compatible libraries and things to drive them.
Mm-hmm. Not with the NetDuino, but so I think that's a really good segue question of, okay, well, you bought a microcontroller, maybe you don't want to go with the Grove, but you want to go with another shield, so like kind of where do you start? And so I'm going to be very sort of North American centric here, where the two places I like to buy things from would be SparkFun, so sparkfun.com, and adafruit.com. And, like these two particular sites I think are really great and easy for beginners to get into because let's see if they have the NetDuino in here. Let's see. They have a book. Let's see. NetDuino.
The new version, NetDuino 2.
Yeah, it looks like the NetDuino Plus 2. So the nice thing I like about shopping on SparkFun is that, it tells you what it is, but then it usually gives you a bunch of interesting documents here. And previously, when you used to go shop for electronics, you would get a data sheet. And I'm going to see what this one looks like, but most of the time they're like pretty horrific. So what kind of information are you going to get out of here? Like probably a bunch of gobbledygook right now because none of this makes sense, right? And it's 180 pages. So who's going to read that? I don't know who's going to read that. So the really nice thing about SparkFun and Adafruit is they typically give you examples, or they sort of build libraries around it. So I don't see any kind of linked from here, which is interesting.
I can help you with that one. That's at least and it's mostly incompatible with the Arduino shields. And most of the Arduino shields, at least the ones I've used, are kind of dumb shields, like servo connected or power boards. So there's nothing really, there's no logic on the actual shield. With other ones that might be more complex, then you have to, it'd be a little harder to write your objects, or code. There's not as much of a community for the NetDuino. There's only thing for the Arduino. You can probably take the Arduino code and figure out what it does and just rewrite it in .NET.
Okay.
Yeah, community for Duana is not good, is it?
Yeah. But
It's good, I enjoy it.
Yeah.
I like it. It's the two as well, 2 Plus comes with, I think it's got Ethernet and mini SD on it as well.
Yeah.
So.
Yeah.
Is the only difference that it's C# and .NET? It's the same functionality as the Arduino.
Is the Arduino just straight C?
So the Arduino IDE is actually simplified C++. And by simplified C++, I mean that if you were typically writing a C++ program, you would have like a header file, and then you would have your app file, and you had to be really strict in terms of a whole bunch of C++ stuff and garbage collection, all these things. So the Arduino sort of language and IDE abstracts a lot of that away. So when I kind of look at it, it looks more like Java. It's much more high level than C++. And you don't have to have header files. If you do want to write in C++, you actually can. and write libraries. So typically, if you're getting a library from someone, it will have been written in C++. And so you'll see like these libraries connected to your very simple Arduino sketch. But so it's C++ or Java. I would actually say it's more like Java. And then it just gets compiled down. And as a sample, like here's like the Arduino reference. Let's see, I'll just pull it up for like digital write. So it looks, you know, this is all the code that you need to write to turn a blinking light on and off. So you can see that it's extremely simplified. Not at all like C++, where it's like a little bit much more of a setup time for it. So I think that was like an interesting question, because you're obviously going to gravitate towards a microcontroller that supports the language that you like to write in your day job. And so sometimes like that's a really good thing that there are all these microcontrollers that you can do that with. But sometimes it's actually good to branch out and look at other languages, especially if it is the Arduino one, because it's so simplified. Or consider any of the Linux-based operating system microcontrollers, because then you could, hopefully some of them might have libraries actually for you, because if it works on Linux, then actually I guess that maybe that won't work on Linux because it's Microsoft. But it could be an easier transition for you to go with a Linux-based microcontroller than to jump to an Arduino maybe. Yeah.
Have you heard of the EZB? It came out last year from Canada.
All right, let's Google stuff. What is it?
Easy-robot.com is the EZ or EZ, the letters EZ.
Oh, easy.
Robot.com. It's actually similar to some of the things you're talking about with the plugin modules. If you go to the DIY in the shop, it's a really idea for little robot building, but it's got a great visual tool to work with. So it does have some limitations. It doesn't ask you to work anything with that scripting language, but I don't think it's very well known this one because it's so new.
Okay, should we watch the video? Who wants to watch the video? Yeah.
I'm DJ Schurz, founder and CEO of Easy Robot, and this is Easy Robot Revolution. Before Easy Robot, building even the simplest robot was very complicated. Easy Robot Revolution is the unification of robotics. Our modular components are called Easy Bits. They connect using clip-and-play technology to create the robot of your dreams. The supplied Easy Builder software includes a robot app store, which we've named Easy Cloud. The app store is full of community-created apps. All Easy Robot Revolution apps include step-by-step instructions in 3D. Easy Builder software includes hundreds of features to give your robot personality and capabilities only thought possible in science fiction movies. Would you like to control your Easy Robot from your iOS or Android device? Introducing Easy Builder Mobile. Using the Easy Builder Mobile, browse the Easy Cloud App Store. Load new robots and personalities. Creating animations to your robot is easy with the Auto Positioner. Add features like speech recognition,
Robot, dance.
glyph recognition, color detection, face tracking, joysticks, Wii controllers, and hundreds more. Easy Builder turns everyone into a robot app developer. When you create a custom robot app or modify an existing app, save it to the Easy Cloud, and it instantly becomes a mobile application. Additional Easy Bits can be purchased from our online store. They're injection molded with high-quality, durable plastic. For those of you with 3D printers, Easy Builder supports 3D printing of every Easy Bit. idea to create your own EasyBit? The EasyBuilder software includes an EasyBit designer. Simply add your designs to create an EasyBit. Submit your creation to the cloud library and share it with the world. Robotics has followed in the PC industry in the late 70s and early 80s. Much like Apple, Easy Robot is making robots accessible to everyone. Imagine how great the world will be when everyone has the power to innovate. Join the Easy Robot revolution.
Yeah, so there's definitely like tons of kits out there. Like I don't even keep track of all the ones that come out on Kickstarter. Like there's always something new, or there's companies like Easy Robot that have, they're looking at that problem that you have, which is that you want to build a robot, but you don't know how. So then they've found like their little niche here to fill the people who want to make robots, and then they have like an ecosystem around it. So it's definitely like a huge trend. And he kind of mentioned too, like we're in this sort of revolution where like I'm definitely seeing hardware looking a lot more like software. So, the Arduino shields, they're like how you it's like how today in software you go and download a library and then you include it into your application using like a single include line. Hardware is becoming a lot like that too now, where you buy modules that are very much self-contained, and it should do what it does very well, but it's very plug and play. So I think we're in this really interesting beginning of seeing all these projects like Easy Robot or like Little Bits. And I wonder, what was the pricing for this one?
For just the processor, it's $99.
Okay, so $99.
With power supply, and the camera, I think, is $60, which is pretty nifty. So the face tracking recognition and everything like that. Just got 1 week ago, so
Oh, nice.
this is nifty. But it's the thing is that as a technical person, you often want to go beyond the interface, and they do have under one of the places down software. I think they've got SDKs for Mono.net and iPhones. You go up on the top. There's a page. Let's see what it's doing. There's the software. And see all the platforms on top, Node.js, and all of that.
Mhm.
So different SDKs on there.
Yeah, so that's great. Anything else that anyone wants to share or ask a question about?
No, I was going to say, it's just costing a lot of money.
Watch the import that.
How is the Edison community? Is it big, growing?
The Edison community is
Intel Edison.
it's growing. So the interesting thing about Edison is that it's backed by Intel, so they have the budget to kind of do bigger events than some of the smaller players do. So they've definitely run a lot of hackathons. I don't know if they've had a London one yet, but I can imagine that it's probably on the roadmap somewhere. But in North America, especially like specifically in the US, they've done a lot of what they call road shows, which are hackathons. And I asked this question yesterday in my workshop, who's been to a hackathon? And only one person put up their hand. So in this room, who's been to a hackathon before? 1, 2, 3. Yeah, so I find that really interesting because I don't know if it's a North American thing or a generation thing, but hackathons have like really taken over North America, where I'm from Toronto and there's a hackathon, I swear at least 2 a month, if not like some weeks I feel like there's a hackathon every week. And across North America, there's a hackathon going on all the time. And a lot of the times now, like a lot of these hackathons, it used to be very software centric, but now a lot of hackathons are happening that are incorporating hardware. There's companies called Major League Hacking that actually will bring in a lot of consumer electronics, like who's heard of the Mio before? Like the ARM, I'll just pull up a picture of it, Mio. Like they might go and buy like a lot of kind of consumer products like Pebble or a Mio and actually bring them into hackathons, and typically a lot of students work, like they're serial hackathon users. Like I went to a hackathon where it was a first year university student who started going to hackathons when he was in grade 10, and this was his like 8th hackathon, and I was like, wow, these kids are just gonna like blow us away. But companies like Major League Hacking will bring hardware to hackathons. So Intel has really gotten into that space where they're always kind of represented at a hackathon. So the community is definitely growing. But I think it's one of those things where we have to give it a little bit of time to see how that's going to shake out, because you know, other little small startups also have great communities too. But you know, I'm part of the Intel community, so I guess I'm awesome, and so the Intel community's awesome. I don't know, like, so I think you kind of have to kind of like poke around a little bit and see if you know, if your answers get answered and that sort of thing. But I personally think that Edison is very powerful, and their community support is pretty responsive.
The latest Edison board is the second one, isn't it? The second gen.
No, there's only one generation right now.
The second.
Oh, so they have another. Intel has another microcontroller that's coming out that's specifically geared towards wearables. It's obviously not out, but this is what it looks like. It's the size of a button. So you can kind of see, like, this is kind of the competition and landscape that we're entering into, is making microcontrollers fit into buttons. So, you know, we're going into like crazy territory here. And then some people who are really interested in wearables have actually jumped over the making components smaller, and they've actually started just talking about implantables now. So, you know, in the near future, we're just going to have chips in our arms and in our eyes. And somehow people are already talking about this, even though we haven't even gotten to this being released yet. So we're kind of in an interesting landscape.
Like you have the easy robots, do you have something for the drones?
I'm sure there. Does anyone have a drone? It sounds like you.
Yeah, that, and the Easy Robot chip, they've actually knocked on a drone, and it flies the drone around. So you go there and you look at the drone and see that they've actually got it as one of their objects is there is a drone as already an object, and you just plop it on there and you fly it around it with a camera on it and all kinds of stuff. So yeah, it's in there.
There you go.
Did the
Anything?
Microsoft Gadgeteer ever take off?
Pardon?
Did the Microsoft Gadgeteer ever take off?
I have never heard of it, so that could be an answer of no.
I've not heard of it for a long time.
Gadgeteer? Oh, Microsoft.
Yeah, Gadgeteer. That's it. Up. That's it.
I have never heard of this before. Well, sometimes they put in like this footer will just automatically update. So I can't say I've seen this before, but I think that's a good question, because you're inquiring on things that like you personally would like as a tinkerer and getting into hardware.
Stuff I found when I was looking to buy one, which was about 18 months ago.
Mm-hmm. So I think that's perfectly like fine for someone to like be interested into hardware for like personal reasons. But I actually work a lot more with hardware with like startups and at hackathons and that sort of thing. So I kind of gravitate more towards what I see the cool kids or like the university kids using, which tend to be a lot more of these polished consumer products. Like most university students I see, they're moving away from Microsoft and like going to like Macs and other sort of things that work in sort of like the Apple ecosystem. So I'm not really seeing, this sort of stuff here that might be kind of more like .NET hasn't really come across my radar, because I don't really see people using them at hackathons or products being built on them. But I think at the same time, like if you're just interested in tinkering, you should pick the microcontroller that fits your needs. You shouldn't have to pick what's popular. And the only reason why you might want to pick what's popular is because the community around it is growing. So actually, there's a new company called or actually, let me go back one step and go, who's been on Instructables before? Okay, a few people. So for some reason can't spell right now. Instructables. And that is not it. Okay, instruct. Okay, so Instructables is actually a really old company. They got bought by a 3D company whose name is escaping me right now. But Instructables has been around for like over a decade, and they just have a bunch of tutorials of things that you want to make. So I find that Instructables is actually a really good site for you to browse around on if you want to learn how to get started, because everything is picture-based. So let's see, let's look at this one. And so depending on who wrote it, they're typically very picture-based, sometimes video. So I find that Instructables can sometimes have really good tutorials for helping you learn. It obviously depends on who wrote the tutorial, but I do find that they just have tutorials on everything, like from making pie to using a Raspberry Pi. So like they have everything. But a new company that just came out is sort of in the same vibe as Instructables, but it's called Hackster.io. It's sort of the same thing, but they will focus only on technology, and a lot of times specifically on microcontrollers. So like if we go into the Arduino stream here, you'll be able to find projects, like home projects that people have done on Arduino, and then they'll have a little tutorial around it. Or at least a showcase and like linking off to like their site. So so Hackster.io is a good place to figure out like, you know, what's kind of popular and what the community is working on. Because once something gets popular, like Hackster.io will like kind of add it as a category. And so if you're interested in the Edison, I know that there's an unofficial Edison community or stream, if I remember where it went. I think they changed the homepage on me. Platforms, I think. Yeah, so, you know, they have this Spark, Arduino, Raspberry Pi, Edison, you know, Electric Imp. I didn't talk about the Teensy, but Teensy is like the really small Arduino microcontroller that's really popular. You know, the Bean. So I guess if you had to get started, I would probably go and browse some of the projects on Hackster.io and get some inspiration. So that was like a really long-winded answer to your like, have I heard of this .NET controller? But hopefully that answered that. Okay, 5 more minutes. Do you guys have any other things that you want to share or ask me?
I was just going to ask, have you seen anything that really think is brilliant and built, you know, that people have built or you built yourself using all this technology? People, I know you sort of started with the art side of it, but...
Yeah, I think, you know, like, it's on my screen here, but I think Pebble is really interesting. And let's see. Might have, oh, I can actually show you a picture of something I made, but let's see. So this is an early Pebble, which I think is really interesting because he took apart, the founder of Pebble took apart like an old cell phone, and then in the background there you can kind of see that there's an Arduino microcontroller. So an early Pebble was prototyped on an Arduino, so that can give you inspiration for, I think they're almost at 20 million at their current Kickstarter. If I'm, let's see, okay. Yeah, so they're really close to getting 20 million on their second Kickstarter. So to go from, you know, this thing to 20 million is kind of cool, I guess. So I think that's a really nice story of, you know, someone who saw a problem, which the story kind of with Pebble is that he's an avid cyclist, and so he really needed to know what's like who was calling him and that sort of thing without reaching into his pocket, because that's kind of a hassle when you're riding a bike. So he became like, he identified a problem, prototyped something, and then stuck it out for like 6 or 7 years and has become like quite a big player in terms of smartwatches. And so I'll actually show you, I could not fit it into the presentation because I didn't know how to, but this is a prototype that I've made, not that one. Let's see. And I'm still working on it. And so this is a prototype that I did at a hackathon. I had the idea before the hackathon, but I like cycling in Toronto. I cycle all the time. And I typically know where I'm going, but sometimes when I have to get to a place that I'm not familiar with, I like to at least have like some sort of map or navigation taking me there. But the maps on your phone are not geared towards cycling at all because it's screen-based. You have to like look at your phone, pull it out like when you're stopped at an intersection, which is pretty dangerous. So I built this prototype for haptic feedback bike navigator. So it's set in the way where it's a holster style, but most of the electronics are in the belt. And so there's vibration motors, there's 8 of them around the belt, so you get 360 buzzing. So when you need to turn left, it buzzes left. When you need to go right, it buzzes right. If you miss your stop, the back buzzes. And so it hooks up to an Android app that gives you the turn-by-turn directions. Uses the light blue beam, so it communicates over Bluetooth Low Energy, and then it buzzes your belt. So obviously, like, it's not finished. This is not my finished product, but I'm actually something that I am working on. So who knows? You might see me on Kickstarter in like a year. So you can tell everyone you knew me where I was famous. I have 1 more minute. No. So thank you so much for coming.
Sorry,
Oh,
last question.
yeah. Okay.
Intel, you said they're coming up with Curie, so they're not planning to upgrade Edison anytime now.
Oh, they're always going to upgrade, like, because it's all about the form factors that you need to fit into. So the Curie is going to be for wearables, and then the Edison will be for like everything else. Yeah, but that's unofficial Intel word. That's me just saying as a company, you're gonna keep on upgrading your previous things until it doesn't have any more lifespan. Okay. So thank you so much for coming, and I'll see you around the rest of the festival if you have any comments or questions for me. Your eyes, and then the computer starts drawing you, so the platform starts moving. And it's a really interesting experience because, it's you kind of holding a pen and you're kind of drawing your self-portrait, but it's actually the computer seeing you. So it's this really interesting interplay of who's actually making this artwork. Is it kind of you or the computer? What is the artwork? Is it the experience of sitting there, or is it the piece of paper you get at the end? And so for me, I did my blind self-portrait making a zombie face, and I think it turned out pretty well. Another piece that I really liked that was actually from 2001 is from an artist called Janet Cardiff. So this was an installation at the San Francisco Museum of Modern Art. It was called The Telephone Call. And so what happens is that you get to the museum and you ask to see the telephone call, and they give you a handy cam and headphones. So you have to carry around a handy cam, and you have to carry around and point it at things. And then you have audio in your headphones. And it's kind of like a museum tour in some ways because you're kind of holding up the screen and you're seeing the museum filmed at a different point of time. And this was 2001. So this is sort of like really early augmented reality. But the interesting thing was that it wasn't like a museum tour. It was actually more of a spy mystery espionage story, so it was actually kind of creepy. So it wasn't a museum tour where it tells you about the artwork. You're actually being led by the artist's voice and the video to tell you to go places in the museum. And it's really interesting because not only do you have this handy cam, but the way she records the sound is binaural. It's called binaural recording. So she has this mannequin head that she tapes microphones to both sides of the ears, and then records the sound while walking around. So when you get it played back. And so for me personally, when I started getting into electronics, I was really obsessed with lights. So I built this LED light sculpture. where I actually had to hand solder about, Canadians say solder, by the way. I had to almost 1,000 LEDs I had to do by hand, because back in that day, you couldn't just order this magical sheet of LEDs. And then because there was no overnight shipping of circuit boards, I was running out of time, so I had to hand do all my circuit boards. I did 10 of these. But I kind of realized that I wasn't going to make a living out of being a new media artist, or I could make a living, but I'd be really poor. So I became a web developer. So I made sites like this for Nike, like companies, and I really enjoyed that part also of my career, because I really got into deeper into front-end development and coding. But I always continued to do hardware as sort of a side project. So I kind of realized actually that I could still continue working in that sort of interactive space, but do it under the guise of teaching. So I would actually do workshops where, this is one of my workshops where it's an Arduino-powered robot, but you could control it using your Android phone. And it's not as creepy as it looks here, it's just because it's dark. It's actually very adorable. But I would actually teach these at workshops that I would do. And then, crazy enough, I realized that people will actually pay me to teach technology. So I've done contract work for Google, specifically with the Google Chrome team, doing tutorials for front-end web development. And then, crazy enough, like nowadays, I actually work with Intel's IoT department, their Internet of Things department, as a developer relations. So I help improve their onboarding experience, specifically for people at hackathons. So it's kind of great that, after all this really So how was everyone this afternoon?
Good.
Good. So it's the last session of the day, so you can just kind of relax. If your brain's not already completely full of other information. So thanks for coming to my Interneting Your Things talk. It's a small room, so it's nice and small, and I'll probably have lots of room for Q&A afterwards. So if you came here with a question, feel free to ask me at the end, because I'm up for answering anything that I can answer. So I'm Pearl Chen. And I actually brought this name badge with me. It actually blinks my name in LEDs. And so I'm from Canada, and thanks so much for DevWeek for having me back again. And so my name is Pearl Chen, and I have to admit I have a microcontroller addiction problem. I keep on buying microcontrollers, and sometimes I use them, sometimes I don't, but I just have this vast collection of microcontrollers. And I like to buy these microcontrollers under the guise of work, because back in the day, in a former life, I dropped out of computer science and became a new media artist, but not that kind of art where it's like paintings, but art that you were expected to interact with, so things that you could touch, or you would enter a room and it would sense that something has changed. So it was interactive art, and the program that I was in was called New Media Art. Back in the day, it made sense to call something new media, but now new media is old media, so it doesn't make sense anymore. So most of the time you hear it as interactive art. And a lot of people don't really understand what my background is, and especially I'm here at a software development conference, and I am myself a software developer, but I have this kind of weird background. So I want to play show you 3 examples of artworks that I really like that sort of show where I came from. And this is a project from Kyle McDonald and Matt Metz called Blind Self-Portrait. So what happened in that video was yourself as a participant, you go and you sit down in front of a computer webcam. So you sit down in front of it, and then you rest your hand on a platform and you hold a pen on top of a piece of paper. And so what happens is the webcam, it sort of takes a video or picture of you and uses computer vision to analyze, you know, what you look like. So it tries to figure out where your eyes are, what shape your nose is, you know, the shape of your head. And then you actually close your, it's sort of like supersonic stereo. And it actually really feels like you're in that space that got recorded, because you can really judge distance of like where objects are. And when someone is whispering in your ear, you really actually feel like someone's whispering in your ear. And so it's really interesting because at one point in this spy story, she leads you to a door that says emergency exit only. And you know, as a person, you wouldn't typically go through that door. But in the video and the audio prompts you to go through the door, and someone goes through the door. So you have to, at that moment, decide, should I go through this door that I really shouldn't be going through? And so there's like this really interesting audio clip where you end up in the stairway. And if you do listen to this audio clip at home with your own headphones, it actually sounds really creepy, because it does sound like someone's in the stairways with you. But when you're there in person, like, you know no one's there, but the audio is so real that you just get kind of scared. So I thought it was a really great installation just using technology, and it was very foresighting of how people want to use augmented reality today. And kind of my last piece that I'll kind of show you to give context is it's actually a London company called Qt Circuit, and they do a lot of wearables. So this isn't an art installation, it's actually a creative wearable. It's a Bluetooth accessory for your phone, where you wear this sleeve that has pleats in it, and when someone sends you a text message, the pleats actually ruffle up a little bit, so you can tell from the pleats and the pattern in it who's calling you or who's texting you. And then it's really interesting because it's not just a notification system. When you want to reply back with a text message saying, I'll call you later, you actually like smooth down the pleats on your sleeve. So it's very physical. It's a very physical interaction. And it's really interesting because this was done in 2005, so 10 years ago. And I think it still looks really great.